let's get started with programming, which is the paper 2, computer science paper 2, A level, of course. Yeah. So the first topic that we need to get started with is algorithm design and problem solving, which is just a continuation from what we were doing when we were doing GCSE, right? So the first thing that you're going to appreciate now on this one is the part on these things is introduction. The first thing is algorithm. Basically, when we talk about an algorithm, we are talking about a step-by-step way of solving a problem, right? A step-by-step way of solving a problem. But we might need to fine-tune that definition now as we are now doing A level, saying that it's a finite, right? It's a finite sequence of steps. So when we talk about the part of it being finite, we are saying that it is somewhere that where it starts, where the steps starts and where they end. That makes it finite. They have to end. Sequence of steps that are supposed to be unambiguous, right? When you're saying that they are unambiguous, you're saying that the solution that you're going to be getting from an algorithm is supposed to be correct and not causing us to be having different outputs at the end of the day. When we follow a certain sequence of steps, we're supposed to be getting the same output. When something is said to be ambiguous, it means that it is different solutions or different ways of doing it, or different solutions at the end of the day, yeah. But it's supposed to be giving us the same solution at the end of the day. No matter we can actually have different ways, but at the end of the day, let them give us the same solution, making them unambiguous. So an algorithm, we're saying that it's a finite sequence of steps that are unambiguous, right? That are followed when solving a problem. When solving a problem, that's one thing that you can start with as far as an algorithm is concerned. So whenever we want to present an algorithm, we may use different ways. We may present an algorithm using a flowchart. We may present an algorithm using a pseudocode. We may present an algorithm using even structured English. And you'll see that at some point when you feel like you now know exactly what you're doing, you can actually even present an algorithm straight up using the program code. So basically that's what we have. We can talk about representing it as a flowchart, as pseudocode, as structured English, and even as a flowchart. That's some of the ways that we're going to be using to present our algorithms. So for the meantime, we're going to be using flowcharts and pseudocodes mainly when we are presenting our algorithms, right? A flowchart is the one that's going to be coming through with symbols, whereby we have some diagrams or some charts that are going to be connecting together to tell us the sequence of steps that you're going to be taking. Then talking about pseudocodes is now a program like, it's more like a program code like kind of the display that you're going to be using. I understand that from your IGCSE, you have actually done some pseudocodes before. So that English, they are like English-like statements that you're going to be using. Then program code, we're going to be probably using Python or any programming language that you can actually that you're going to be choosing to use it. But rather, Python is going to be one of our most common language. So there's some constructs, or there are some things, there are some elements that you're going to be seeing in most, or if not all, algorithms that you're going to be seeing in your entire career or in your life as a programmer. When we call those programming constructs, you are never going to be missing these four. You're going to be finding them in almost every program that you're going to be seeing. The first thing is assignment. When we talk about assignment, we're talking about the act of giving a value to a variable, which brings us to a new word that is called variable that we might need to talk about. A variable basically is just a named memory location. We're giving a name to a memory location, right? And what makes it now a variable is that the value that is going to be stored in this memory location is likely to change. You get the point? So a variable, it means that the value that is stored in this location is likely going to be changing. So a named memory location containing with a value that is likely to change. With a value that is likely to change. Likely to change. We'll talk more about these as we'll be going, and you will see them many a time. So opposite to a variable is a constant. A constant again is still a named memory location, but the value that is contained within a constant now is not going to be changing throughout the course of the program. You get it? It's still again a named memory location, right? With a value that will not change. The value that will not change throughout the program. Come on. Throughout the program. That's basically it. So that's the part on assignment. Okay, that's the part on a constant. So when you're talking about the part of constant of assignment now, we're saying it's giving a value to a variable. Suppose that I create a variable, let's say age. I create a variable like age as an integer, like this. So my variable is called age. So the name of the location is called age, is integer like this. When I now then go ahead and say age, let it have a value like 5. This now is the act of assigning. This is called declaration because I'm creating a variable that is called age, right? When I'm now giving it a value now, we're now calling this assignment. So whenever you see a value being given to a variable, we call that assignment. Then the second thing that you're going to be seeing is sequence. We're talking about the flow of the program, the logical flow, the chronological order in which the program is following, right? Check this out. I could not assign before I declare. That's the sequence on its own. I first have to declare a value, then I assign. I have to declare a variable, then I assign a what? Assign a value. So this is the sequence. I have to first declare, then I assign. I don't assign, then declare. That is not logical. So when we talk about the pattern sequence now, we're talking about the flow or the logical sequence, the logical flow of the program, the chronological order in which the program is following, right? Selection is the act of making a decision. We'll talk more about this in detail, but just know that whenever we want to make a decision in our code, that's when we're going to be seeing my if statements, my case statements. These are now going to be coming through as our statements that we use whenever we want to make a decision. So selection is making a decision. You see this is with a sign of a rhombus when we are doing flowcharts. But basically you see that selection, whenever we are talking about selection, we're talking about the part of making an option. There are different choices that you can choose, so we need to make a selection. Then the last or the fourth programming constructs or a basic construct is iteration. In most cases, it can actually come through as loops, or it can come through as repetition. So we're talking about the part on iteration. We're just talking about the part on repeating a certain block of codes. We want to go ahead and repeat a certain block of codes until a certain condition is met, or until for a number of times. So we'll talk more again about the types of iterations that we have, but just know that whenever we're talking about iteration, we are repeating a certain block of codes. That's iteration for you. Then counting and totaling, these are not necessarily the basic constructs, but we are always going to be seeing these values, like these sections or these constructs again in programming, whereby we are saying that we are increasing a value by a new value. More like we want to keep a running total. We want to keep a running total of probably sum. We are running a code that takes 5 numbers and gives us the total. So we might want to increment the value of total whenever I get a new value, adding the new value to the total amount that I'll be having. Suppose that I want to get 5 numbers. If I take the first number as 1, then my total is 1. If I take another number as 5, then my total is now 6. If I take another number as 10, my value is now 16. My total is now 16. So what we are having there is what we are calling totaling. We are having the value, we're keeping a running total we're always incrementing the value of total with the new value that we would have got, a cumulative amount, right? So the accumulation of those numbers is what you're calling totaling. Then the last part now is counting. Counting is just keeping track of how many times you have done something. How many times have you stayed in a loop? How many times have you done some certain set of instructions? So this is basically whenever you see something like this, count is now equal to count plus 1. That's basically what you are saying is counting, or any other variable that you would have used, or index, whatever variable. As long as we are incrementing by 1, we're talking about the part of counting. Even when we are decrementing again by 1, that can actually come through again as counting. We'll give both examples as we'll be going. But just know that as we are introducing ourselves, as we are getting started with programming, we need to know that there are these different elements, different programming constructs that we need to be always sure of. Yeah, that's a start. We will talk more about this as we'll be going. But I'm going to be sending you an assignment to work with as far as this section is concerned.